Hi all, you may have heard this question so many times, bias variance trade-off. And before stepping on to this bias variance trade-off, you may need to know what bias is and what variance is. Bias is when a model makes wrong assumptions and missing patterns. I'll help you with an example. Okay, suppose that your data set is looking like this. Okay, somewhat a curved data. And I am going to fit this pattern with a straight line, and as you can see, this is not a good model, right? Here we can say that this is the case of underfitting. So underfitting is the scenario where we deal with high bias, and here it is not training, it will not perform on the training data as well. And there is another case as well. Suppose that my data point is look like this, and my model is going to train each and every patterns and every random fluctuations in this data and every noise data, and this is the case of overfitting. While this may seem good model, but it is not, because if it is going to predict a point on the unseen data, it won't perform well on that unseen data. So that overfitting is the case of high variance. So as you can observe, these two cases, both of these underfitting cases and overfitting case, both of these cases are not favorable, and we need to find a right balance between this high bias condition and high variance condition. And so bias variance trade-off simply means that to find a right balance between this overfitting and underfitting. That means the model does not be too simple or not too complex, so the model performs well on the unseen data. If we are going to plot the plot, it will look like this. Suppose that my data looks like this and the best fit line should be like this. Okay, it can predict the unseen data too well compared to this two models, and this is the bias variance trade-off, is to find the right balance between high bias condition and high variance condition. Okay, hope you are clear with this topic. Thank you.